No?
Not this week.
Oh.
Not this
I
week.
was like,
Next week we should.
Next.
Alright,
I like your
so we'll spend probably 4 to 5 days on this section. And then we did talk about taking our test after that, so test is next week. Let's see what exact day I'm thinking, like Wednesday-ish next week, but we'll kind of see. Alright, so where we ended in the last section, we saw that when we did the limit as n goes to infinity of the sums from 1 to n, we were computing area, right? And that was what we did to find the exact area. We also saw that when we were talking about distance, because we said if you had the velocity function, when you went backwards, you had the distance function. But we see this in a lot of different situations, and it actually has a name. What you were doing, without knowing it, was what's called a definite interval. And so the notation for that, it's a really like tall, skinny S. And so this means the integral, starting at point A and ending at point B, of your function. And then you always have a d something at the end. That tells you that x is the variable. So if I had like a's and b's in there, those would have to be constants in this. X is the only variable. Just like when we did the derivative, it was always in terms of some variable, right? When we had like x's and y's, we had to do, every time we did the derivative of y, we had to put dy dx. Or when we did all of our rates, it was always d something dt. T was the variable. So this notation is just telling us that x is the variable here. If you see any other variables, they're just holding the place of a constant. And so that is the same thing as if I did the limit of the sum of the areas of all those rectangles that we were seeing before. So in this notation, f of x is called the integrand. That's the thing we are taking the integral of. A and B are called the limits of integration. A is our lower limit, or the starting point. B is the upper limit, or the ending point. The next slide I have on there is what I already said, that the dx just tells you that x is your variable. It doesn't mean anything by itself, so you only see that dx when you also have an integral. And likewise, if you have an integral, you have to have the dx with it. They go together. Yes, it might be a different d something, but you have to have those together. All right. So, the definite integral can be used to calculate the exact areas under these curves. And we talked about the more rectangles you have, then the more accurate it is. So the best option we had was to do the limit as n goes to infinity, and that gives you the true area. So in this notation, the integral from a to b is saying, starting at a and ending at b, what's the area under the curve f of x? Okay, that's what it means in terms of the graph. Now, another thing to realize, we haven't had any of these, but some curves aren't always above the x-axis, right? Sometimes they're below.
Whoa.
And so when we have to do above and below, we have to take sign into consideration. Something above the x-axis would be a positive area, below the x-axis would indicate a negative. So the negative is below. So we will have to take that into consideration as well. It depends on the question. If I I said, like the area enclosed, that's just your positives minus your negatives, okay, if I want the total change. But sometimes it might ask for the absolute value of the area, so then you have to calculate all of them separately and add them together. So it kind of depends on the context of the problem. So the definite integral will give you the net area, the positive minus the negative, which is what it says here, so it's just going to give you the top minus the bottom. So if I ask for the absolute value, we would have to separate it and write it differently. Okay, so first theorem of the day. If our function is continuous or has only a finite number of jump discontinuities, then it is integrable. We can do the integral. It will exist. Right, so that's just telling us if we have a continuous function, we can do the integral for it. When we do these integrals right now, we are going to set it up like those area problems we were finishing, or we ended with in the last section. The change in x is the ending point minus the beginning point divided by n. X sub I is your starting point plus the change in x times I. That should be familiar because we were already doing this. The difference is I'm giving you a different notation for the same thing that we were doing before.
So it's exactly the same.
Different notation, but same thing. So if I ask you to use those sums to evaluate this interval, I need my change in x. Right. Ending minus beginning divided by n, so it's 4 over n. X sub I is always the starting point, so 0, plus you're counting by 4 over n, so plus the change in x, so 4 over n times I. And that just turns into 4 over n I. So if I'm asking you to do the sums to calculate this, we are going to do the limit as n goes to infinity of the sum from 1 to n. Okay, that is replacing this integral here. Now my function. So when I do this, these x sub i's replace my x's up here. Right, so my function is x cubed, so it would be 4 over n I cubed minus 2 times 4 over n I. That's like the height of the rectangles. The dx is like the width of them. The dx is your change in x. So that's the 4 over n. Alright, so we're setting them up, but it's almost a little bit easier because we have that limit written above us, so it kind of helps solidify what we're doing. We're basically taking this, you replace your x's with your x sub I, you replace your dx with the change in x. Now we have to work this out to the point where we can do the summation rules. So we have a limit, saying goes to infinity, sum from 1 to n. Okay, 4 over ni cubed, so 4 to the third, 64 over n to the third, I to the third, minus a over ni, times 4 over n. So now if I distribute my 4 over n, 64 times 4 is what?
256.
N cubed times n. Minus 8 times 4, root 2, n squared I. Now what? Okay, so we know the summation can go inside here. At this point, you don't necessarily have to show all of that work. I'm doing the 256 over into the fourth to kind of come out, and then you do your I cubed rule. What is the sum for I cubed?
N squared. N plus 1 squared over 4.
Minus 32 over n squared. What is my formula for I?
N times n plus 1 over 2.
Okay, so at this point, when you use the formulas, notice the summation is gone. Okay, I used my formula for how to add it up. Now, I definitely don't want to try to do my limit yet. We want to clean this up as much as we can. So 256 divided by 4 is 64. I could take out 2n squared right away there. Can I go ahead and FOIL out the n plus 1 squared? 32 divided by 2 is 16. And drop one of those n's. So I would probably just distribute and simplify as I do this. So can I distribute my 64 and divide by my n squared at the same time? So it'd be 64 n squared over n squared, which is 64. 128 n over n squared, so 128 over n. 64 over n squared. If I distribute my negative 16, so negative 16 n over n is negative 16 minus 16. Alright, lots of algebra to this point. Are there any questions on how I got there? Now what do we do? So anything with an n on the bottom would turn into 0. So I'm just left with 64 minus 16. So the value of my integral is 48. Or is the area under that curve from 0 to 4? Turns out to be 48.
So it's just the same thing that we did, except we just
Different notation.
took the notation and put it into our summation little thing.
Alright. What?
That's all negative minus.
This one, I'm asking you to take this limit and change it back into an integral. So I'm not even asking you to calculate it, just can you write it and tell me what it means? So my integral, where would it start?
-3
Okay. So we have the limit of the sum. Look back at your definition if you need to. Alright, all of that goes away. Instead of f of x sub i's, we should just have f of x's. So the x sub i's are just going to change into x's. So 2 minus 3x. I don't care what the subscript is. I don't care if it's I or I minus 1. It doesn't matter for writing the integral. Change in x sub I gets turned into what?
Yes.
And that's it.
Do we put the f in front?
Hmm?
Do we put f in front of 2 minus 3x?
No. So basically, the limit and the sum together turn into your integral. This, just change your variable to a plain x. And the change in x sub I is your dx. That's all you have to do in this. You might even see instead of x, you might see like an M. It stands for midpoint, which we'll talk about. But if you do that same thing, you just change it back into an x, rewriting the integral. So like the first 5 questions on your homework tonight are literally, I gave you this limit of the sum. Can you write the integral from it?
Oh man,
I know, it's a rough assignment,
that's scary.
isn't it? It's gonna take hours and hours.
I might
How many
have done by
columns
tomorrow.
are there?
It's like a trig
6?
identity.
There's actually 4. The first 5, but there's only 40.
Evaluate. Okay.
Okay, so this time we're going to calculate. So what do I have to find first? How do I do that?
B minus A, top minus bottom.
Do yeah, top minus bottom over n, so 3 over n. Okay, how do I get x sub I?
Times your lower limit by, or lower limit plus change in x times I. I'm sorry.
Because we're starting at 2 and we're adding multiples of 3 over n. Alright, so now take this integral and we have to put it into the limit of the sum. So the limit as n approaches infinity of the sum from 1 to n. Alright. 3, what am I replacing x with?
You're the whole thing, x sub I.
So instead of x squared, I have 2 plus 3 over n I squared plus 4. And dx gets replaced with times 3 over n. Can I distribute? Can I combine 2 things at once? Here's what I'm going to do. I want to distribute my 3 over n to each term. So that'd be a 9 over n. And then I'm also going to FOIL the inside of that parenthesis at the same time. Is that okay? So if I FOIL that, I would get 4 plus 6 over n I plus 6 over n I, so 12 over n I. It's 9 over n squared I squared. Plus the 4 times 3 over n is 12 over.
Would you cut off if we forgot to put like the limit is in the process infinity in the summation by or 1 to n, like every single step?
Oh, you should probably have it. It's good notation. Otherwise you'll forget to do it.
I'm dumb. How did you get the 12 over it?
You distributed the 3 over n to the 4.
4 times 3 over n.
Oh, the.
Oh, this?
Uses 3 n.
From when I FOILed.
Oh, it's 6 plus 6 equals 12. Okay, never mind.
Yeah, I've had this twice. Other questions right now? What do I do next?
Distribute the 9 over n.
From 1 to n. Distribute that, we get 36 over n plus 9 times 12, so 108 over n squared I plus 1 over n cubed I squared.
Oh no.
12 over n.
What are you doing with the 108?
Multiplying the 9 times the 12 by 9 times the 9.
Do we combine like terms or do we just split them up here?
Either way. If I did combine 36 over n and 12 over n, and when I add that up in times, so now I'm doing my summation formula, so the sum went away. What is the I squared, or the I formula, sorry?
N times n plus 1 over n.
Over what?
No, 2.
Or do we do n formulas? Or the I
I did my formula for I.
Where did the 36 go?
I added the 36 and the 12, because they were like terms, and since that's a constant, it just gets multiplied by n, when you add it up. And now I need my I cubed formula, or sorry, I squared, I keep saying cubed.
I did that too. N times n n plus 1 times 2n plus 1 over 6.
And that's just the I squared. Now, just lots of algebra. 48 over n times n is 48. Here I'm going to go ahead and just cancel one of those n's. 108 divided by 2 is 54 times my n plus 1 over n. 81 and 6 I can divide by 3. You can cancel 1 in to start with. I'll go ahead and FOIL those two parentheses. I'm going to break everything apart now. So here, 54n divided by n plus 54 over n. Alright. I'm going to take 27 times my 2n squared and divide it by 2n squared. 27 times 3n, so that would be 81n over 2n squared. So 81 over 2n. And 27 over 2n squared. Now we can do our limit. Anything with n on the bottom goes away. Turns into 0. And 48 plus 54.
1, 2, 9. Adding up is weird because I feel like I always learn to like add like bigger numbers together, but like no.
Gosh, too hot.
I don't want to look at anything.
What?
Pine's scary.
Oh.
Can we get that out of the homework?
Yeah.
No.
Weird.
No.
I can give you a strawberry.
Get over your fear of pie. Alright, any questions on this one?
It's an integral. Oh, it's just.
I want you guys to do this problem.
Oh, never mind. This is easy peasy.
Okay, so what's my integral from
0 to pi
of
x cubed plus x sin x.
alright. Did you get it?
Yeah, solve it.
Yep. Yeah, so it shouldn't
We
be too
should,
bad.
but when do you need to wait on that one? Okay,
Uh-oh.
Oh, we're not done?
I don't know.
I think we could be done.
Oh, we're also.
Alright, I'll stop for today.
Awesome, awesome.
So, I have a handout.
Yeah,
It's due Wednesday.
Okay.
So, you don't know how to do all of it yet.
what?
Are you sure?
So you can for sure do 1 through 5
Easy ones.
and 10 through 14.
Ooh.
10 through.
No,